Okay, this is 9709, paper 42, May, June 2022. Uh, two particles A and B of mass 2.4 and 1.2, respectively, are connected by a light inextendable string which passes over a fixed smooth pulley. A is held at a distance of 2.1, B is 1.5, above the plane, both. The particles hang vertically and are released from rest. In the subsequent motion, A reaches the plane and does not rebound, and B does not reach the pulley. Show that the tension in the string before A reaches the plane is 16 Newton and find the magnitude of the acceleration of the particles before A reaches the plane. So I'm going to draw two FPDs. I'm going to draw first a schematic diagram of what's going on. So we have a plane over here, and we have that A and B, right? A is 2.1 above, so I'm going to put A up here and B over here. Okay. B is 1.5, A is 2.1. Okay, they're both connected to a pulley, right? What happens when they're released? A goes down, it hits the plane, but B does not reach the pulley. So we're gonna draw our FPDs. I'm gonna start first for block A. For block A, this is our y-axis. Since there is no horizontal forces acting, I'm just going to draw the y-axis. Obviously, we're gonna have the weight going down, and we have the tension force of the string. For practical purposes, guys, I'm gonna make the length of the weight, the arrow of the weight, longer than that of the tension because it's falling down. So obviously, the weight should be longer than the force pulling it up. So I'm gonna make the weight like that and tension just like this. Okay, this is for block A. How about for block B? Block B, same thing, but for block B, the tension would be greater than the weight, right? Because block B would be going up. This label says y-axis. Same thing. Weight goes down. And tension is greater because it pulls it up. Let me put vectors. Okay. We know that they're both accelerating, obviously, right? We want to show that the tension is 16 and find the acceleration. So let's start for block A. For A, we know that sigma Fy is equal to the mass of A times the acceleration. It would be nice to put on the side that A of A is equal to A of B, and the tension on A is equal to the tension on B, because it's the same light inextensible string. Okay? What does this mean? What vertical forces do we have on A? We know that it's accelerating downwards, so W is going to be greater than T. So I write W first minus T equals the mass of A, 2.4, times acceleration. We can simplify this. We know that W is equal to mg, so it's equal to 2.4a. Let's substitute. The mass is 2.4, g is 10, minus t is equal to 2.4a. Therefore, 24 minus t is equal to 2.4a. Equation 1 for block B now. Again, sigma Fy is equal to the mass of B times the acceleration. What are my vertical forces on B? Tension and weight, but it's going up, so tension is greater than weight. So because weight of B, it should be better to put weight of B, weight of A. I should have done that to be more precise. Okay, so weight of A I should have written here. Okay, mass of A. Specify, guys, huh? Okay. So T minus the weight of B, because T is greater, it's going up, so it's T minus the weight of B, equal to the mass of B times the acceleration. Let's substitute. So T minus the mass of B times G is equal to the mass of B times A. Why WB equals MB? W is equal to mg. That's why I substituted. Okay, continue. Mass of B, 1.2. G is 10. Whoa, G is 10. So 1.2 times 10 is equal to the mass of B times A, 1.2 A. So this is equation number 2. We can find an expression for T. Actually, no, let me simplify this more. 1.2 times 10 is 12. So therefore, T minus 12 is equal to 1.2A. This is equation 2. So we have two equations. Let's solve. I can find an expression for T. T is going to be equal to 1.2A plus 12. So over here, instead of T, what are we going to substitute? 1.2A minus 12 is 24 minus 1.2A plus 12 is equal to 2.4A. Solve this, you can get 24 minus 1.2A minus 12 equal to 2.4A. So you're going to get 12 is equal to 3.6A. So 12 divided by 3.6, let me just make sure. 10 over 3, which is 3.333. I think they tell us to keep it to 3 significant figures. So you're going to get A is equal to 12 over 3.6, which is equal to 3.33 meter per second squared. How about, what are they asking in the question? They're saying, show the tension is 16. So I also have to find the tension. We said tension is equal to 1.2A plus 12. So tension is equal to 1.2 times acceleration, 3.33, plus 12. Put it in your calculator. 1.2 times 3.33 plus 12. You get 15.996. So to two significant figures, as a three significant figures, 16.0 newtons. Just like that, part A is done. So we showed it 16 newtons and acceleration is equal to 3.33. So for part A, you would get 1 mark for, 2 marks for Newton's second law. So 2.4 G minus this for these two. So we'd get 1 mark over here. And 1 mark over here. Yeah. Attempt to solve for A or T and for the correct answer. So basically you solving over here. And then for your correct answer. Okay, this is how the 4 marks are distributed. Okay, for part B, to find the greatest height of B above the plane, we're going to go back to our diagram here. We're going to see that B, obviously, since A, it went down 2.1 meters, so it used 2.1 meters of rope. So it took B up by 2.1, right? So it was 1.5, you add 2.1, so now it's on 3.6. But you have to remember that B isn't just going to suddenly stop, right? It's going to move up a bit, okay? So for that reason, we're going to have to look at the energies. It possesses some energy that allows it to still move. So we're going to look at the kinetic energy is equal to the potential energy, the GPE. Because the kinetic energy loss is equal to the gravitational potential energy gained. Okay? The kinetic energy is equal to half mv squared. And the gravitational potential energy is equal to mgh. We're talking about particle B. We need to find the velocity. Because you can't find the mv squared if you don't have velocity. And you should know that the velocity of A is equal to the velocity of B. Because they're both accelerating at the same rate, same time, whatever. So VA, let's write it on the side, is equal to VB. And we can find velocity of A because we know how much distance it traveled, which was 2.1. We know that it accelerated to 3.33. And we know it started from rest. So for A, we know that x is equal to 2.1. We know that it's accelerated at 3.33. We know it started from rest, right? So we know we can use the formula v squared minus v naught squared, or called u squared, equal to 2ax. Therefore, v squared is equal to 2 times 3.33 times 2.1. So you're going to get 2 times 3.33 times 2.1, 13.986. So v squared is equal to 13.986, which means v is equal to root 13.986. Okay. We now know v. we can just do now half mv squared equals mgh. So half the mass, we're talking about what? B, right? We're talking about B, so let's put just to make sure. Or you could just write on top for block B. Half times the mass of B, which is 1.2. Go up, it's 1.2, huh? 1.2 times velocity squared, so root 13.986 squared is equal to the mass of B 1.2 times G, which is 10, times the height. And remember, the height we're finding here is the extra distance it's traveled. So the height that I get here won't be the maximum height. We'll see later. Let's continue solving. So you're going to get half, so 0.5 times 1.2 times 13.986. Why am I not multiplying by radical squared? Because radical cancels with the square. So you're going to get 8.3916. So 8.3916 is equal to 12h. Divide now by 12. You're going to get 0.6993. So h is going to be equal to 0.6993 meters. Obviously, that's not the maximum height. What I found now is the extra distance it traveled after it traveled those 2.1 meters from me. So it was 1.5, traveled 2.1, and as it was coming to a stop, it traveled this 0.6993. Okay, so that means the height of B is going to be equal to what? It was originally at 1.5. It added 2.1 because A pulled it up by 2.1. A went down 2.1, so B goes up 2.1. Plus, as it was stopping, it traveled 0.6993. So what do you get? 1.5 plus 2.1 plus 0.6993. You get 4.2993 meters. Let's check this answer. So over here, they accept this answer because we used A equals 3.33. In the solving, they used 10/3. So the 3 marks are distributed. 1 mark for finding V, 1 mark for using this formula, half mv squared is equal to mgh, and 1 mark over here. Okay? So that's question 3. Now question 5. A block of mass 12 is placed on a plane which is inclined at an angle of 24 degrees to the horizontal. A light string making an angle of 36 degrees above a line of greatest slope is attached to the block. The tension in the string is 65. The coefficient of friction is mu. The block is in limiting equilibrium and is on the point of sliding up the plane. So, for this one, it will be a very good idea to draw the FPD. Very simple question, looks very intimidating, but it's very, very easy. So I'm going to draw the FPD first. It's on an inclined plane, so it's going to look something like this, right? So we're going to draw our X and Y axis. We're going to start like this. And no, that's too slanted. I'm going to make it a bit straighter. And then this is our X axis over here. Okay. Yeah. We're going to start first thing with the weight. W. What else do we have? We have many forces here. We have our force, which is pushing it, T, 65 Newton, right? It's a tension force. We also have the normal reaction of the plane. And we have the friction, which is preventing it from sliding up the plane, right? Friction is always opposing the direction of the motion you want. We're pushing it to the right, so it will go to the left. Remember, we have to resolve our forces into Wy and Wx and Tx and Ty. Okay, let's start. We are in limiting equilibrium, meaning that sigma fx is equal to 0. Yalla. What does this mean? Sigma fx equals 0. That means what's on the right is equal to what's on the left. So Tx is equal to Wx plus f. Tx is going to be equal to, oh, I forgot to put the angles. The angle between the horizontal and T is 36. Okay, careful, it's the horizontal. The angle between the weight and the vertical is 24 degrees. Always, the weight and the vertical is the angle between the inclined plane and the horizontal. Okay, Tx, what's Tx equal to? The x component. We have the angle with the horizontal, so we're going to use cosine for the x component. So it's just going to be equal to T cosine 36 is equal to Wx. Wx, since the angle is with the vertical, I'm going to use sine. So W sine 24 plus F. What is F? We're going to use F as mu times N. Okay. T is 65. So 65 cosine 36 is equal to W sine 24, which is mg sine 24 plus mu times N. All right. mg sine 24, we're going to continue our substitution. We get 65 cosine 36 is equal to the mass, which is 12, times g, which is 10, times sine 24, plus mu times N. Remember, we're trying to find an expression for mu, okay? Let's find an expression for mu. We're trying to find mu. So, moving to the other side, you're going to get mu is equal to 65 cosine 36. We moved 12 times 10 sine 24, moved it to the left, so we're going to be subtracting by 12 times 10 sine 24. So 12 times 10, I'm going to write it as 120. 120 sine 24. And we were multiplying by n, so now we're going to be dividing by n. So this is my expression for mu. We're going to call this equation 1. Okay? On the right, we also forgot about sigma Fy. I'm going to continue over here. Sigma Fy, so that's not sigma, sorry. Sigma Fy is equal to 0. What are my vertical forces? N and Ty, it's equal to what? Wy. What's up is equal to what's down. So N plus Ty is equal to Wy. I can actually find N because we're trying to substitute N, right? We're missing an N. So N is going to be equal to Wy minus Ty. Okay, what is Wy? It's W cosine 24. Why cosine? Again, because angles with the vertical. So my y component would be cosine minus Ty. Ty would be 65. This time sine, because my angle for T is with the horizontal instead of the vertical. So with the horizontal, so for the y component, I'll be multiplying by sine. Sine how much? 36. So N is equal to W, which we found is mg. So mg, which is 12 times 10 cosine 24 minus 65 sine 36. So N is equal to 120 cosine 24 minus 65 sine 36. So this is my second equation. I can now substitute this into this. So I'm going to get that mu is equal to what? 65 cosine 36 minus 120 sine 24 over N, which is 120 cosine 24 minus 65 sine 36. Put it in your calculator. You're going to get over here 0.0528, whatever. Remember, we always round to 3 significant figures when it's a non-repeating decimal. So it's going to be 0.0529. And mu is always unitless. Okay, 0.0529. Let's see. What would we get our 6 marks for? Attempt at resolving parallel to the plane. Attempt at resolving perpendicular to the plane. So basically, we would get parallel to the plane, basically horizontal forces. So 65 cosine 36 is equal to 12g. Yeah, so this would be, yeah, F for them is friction. So we would get our first mark for this FBD, the correct horizontal FBD, and this mark here. And what did they say? Perpendicular to the plane. Okay, and then that. Okay, makes sense. So perpendicular to the plane would be, again, the FBD. So we get another mark for the FBD. One for the horizontal part, one for the vertical part. And here's be the fourth mark. Then, basically, this would be one mark. This would be another mark. That's how you get your 6 marks. 2 for the FPD, 1 here, 1 here, 1 here, 1 here. That's your 6 marks. Very easy. That's it for questions 3 and 5. Thank you so much for watching, and good luck in your exam.